So how to use an F tables. This is the critical F table, and I'm going to walk you through it real quick. So the first thing you got to know is what they look like. They're at the back of most of your statistical textbooks. They're online these days, and I'll be honest with you, this comparing your calculated F to the critical F, yeah, it's like 10 years ago. Everything's done with software these days. It just spits out the p-value, which is the best way, easiest way to do it. But, okay, F table, there it is right there. There's a bunch of different versions. Some of them are very complicated, difficult to use. This one is pretty straightforward, and I'm going to walk you through it. All the numbers here in the middle there, those are your actual critical F ratios. Remember, a critical F ratio is if the null were true, then your calculated F ratio should be less than the critical F ratio. So in other words, the number that you got for your final F ratio should be less than what we're going to look up here. Got it? That's only if the null is true. I'm going to say that one more time. If the null were true, then your calculated F should be less than these critical F values here. All right. So first part is make sure you're in the right critical alpha page. Usually it's 0.05 unless somebody cuts it down to 0.01 or et cetera, et cetera. And this book right here, this is from the Keppel book. He's got one for 10%, 5%, 1%, 0.1%, et cetera, et cetera. So make sure that you're at using the correct critical alpha. Again, it's usually 0.05. So this is how you look it up. From your ANOVA table, your column titles up here are your degrees of freedom for your between group. And then the ones going up and down vertically here are the degrees of freedom within group. So let's do one or two. Here's the first example. We have a blank ANOVA. Let's pretend we run an ANOVA by hand. Do all those calculations. That's why we call it a calculated F. And we get these numbers, right? Da, 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 da. So the final F is 6.5. But remember, we need the degrees of freedom from the between groups and from the within groups in order to look up the critical F for this test on a table. So that's why we write it up like this. This is APA formatting, but that means we ran an F test with between groups degrees of freedom of 5, which tells me that there were 6 groups, because that's the beauty of the ANOVA table, right? It tells you right there. So again, if the degrees of freedom is 5, I just add 1 and it's 6. So that's the number of groups in this ANOVA. And for the within groups, so it would be 6 times that equals 582. And I can tell you what your sample size is here real quick. So 6 times n minus 1 equals 582. So 582 divided by 6 equals n minus 1, which means 98 people per group times 6 groups equals 588. That's your total sample size. That's how that works. So this number, 6.5, that is your calculated F ratio. So in other words, 6.5 times as much of the variance is coming from between the groups as it is within the groups. Now, a rule of thumb is if it's 3 or above, you're going to get a significant ANOVA. So, but act surprised. Okay. So again, this is your calculated F ratio. I call it calculated because you had to work for it. Okay. Now we're going to look up the critical F ratio from a table. And to do that, we need these degrees of freedom, right? So we're going to look at 5 degrees of freedom across the top, 582 down the side. Remember that, 5 and 582. So now we're going to switch over to the table. Please hold. And here's the critical F tables. I believe these are all from the Keppel textbook, that tome, that big blue thing. And not to sound braggy or anything, but I have worked out every example in that entire book. Every homework problem I have worked out. That was my Bible, and I learned a lot. And then I was introduced to SPSS, so that's what makes it so much easier to understand. Okay, so 5, 582. So 5 across the top. So this is our row. This is our column. Wait, look at that. I made that mistake. This is not critical alpha 0.05. This is critical 0.10. So this is the wrong page. There's 0.10. Here's our money 0.05. That's our critical alpha. So pretend you didn't see that, but it happens a lot. So make sure you're on the right critical alpha. But again, 5 is our degrees of freedom for a between group. So we scroll all the way down here until we hit 582, 582, 582. So anything over 120 is the same, okay? So say that again, 120 up to infinity is basically the same, 121 up to infinity. And the F ratio, the critical F, if the null were true, should have been 2.21. 2.21, write that down. Okay, so this is the critical F from the table. This is your calculated F from your ANOVA. So if your calculated F ratio is greater than the critical F, you get to reject the null. I'm going to say that again because most of us, including myself, it's counterintuitive and it's almost backwards. So let me do it again. So if your calculated F ratio from your ANOVA, the one that you worked so hard for, is greater than the one listed in the book, the critical ratio listed in the book, you reject the null. Got it? And if it's not, you do not reject the null. So here comes a second example. Let's say we ran a different ANOVA, and these are our degrees of freedom. And our F ratio is 3.08. Now, again, a rule of thumb is if your ANOVA is 3-ish, or above, you get to reject the null. But again, it depends on sample size, how many groups, that kind of thing. So again, that's just a rule of thumb. But we're gonna look at the table and find out for sure. So 2 degrees of freedom, 19 degrees of freedom. Let's go back to the table. 2 and 19. 2 and 19, still at the critical alpha 0.05, yay me. So 2, that's our column between groups. And then we're going to go down to 19. Let me scroll this up just a hair for you. 2, I missed one. Okay, there's 2, 2, 2, 2, and 19 right there. So 3.52, right? 19 degrees within, 2 degrees between. Okay, so 3.52, and let me jump back over. What was that number? It was 3.52. So again, you compare your calculated ratio to the critical F ratio. Again. I know I'm bugging you to death, but it is a very common error. Critical F ratio if the null were true. So your calculated F is less than the critical F. Therefore, you do not reject the null. Let me say it one more time. I know it's making you crazy. It's making me crazy. So if your calculated F ratio is less than your critical F ratio, you do not reject the null. All right, that's it in a nutshell. I hope you guys make sense to you. MGZ out.